Hi guys, I'm going to be presenting my Physics Lab 2 motion of a falling object. The purpose of the lab was to observe the motion of an object that was dropped from rest and falls somewhat slowly straight down. I then captured a video of this motion and analyzed it in Tracker. I constructed a computational model based on physics principles that included only the effect of gravity, and I constructed a second computational model that included the effect of gravity and the effect of drag. The fundamental physics principles in this lab include the force Newton's second law, which shows that the net force is equal to the change in momentum over time. This can be rewritten as the velocity update formula, which can be derived from Newton's second law. The velocity update formula can be interchangeable or written into the position update formula, which is important for this lab. All of these formulas are very important for this lab. Another important formula is the weight of the object equaling the mass times the gravitational acceleration of the near the Earth's surface. And this g acceleration can be calculated from the equation F sub g is equal to gravitational constant, this is a different one, times both of the masses in the system divided by the magnitude of the position vector times the unit vector of the position vector. My system included a paper ball, the surroundings were the earth, as the forces on the system were the air and the force of gravity. The initial conditions are that the velocity was 0 meters per second initially, and that the net force is equal to the weight and the drag force. Assumptions made in the experiment was that the only movement was in the vertical direction, so there was no movement in the x direction or z direction, which is likely untrue. The other assumption is that velocity initial was 0 meters per second, but that is more reasonable as it was dropped from rest. The Glowscript input for the no drag model shows the ball position and ball velocity both starting at 0, the mass being 4 grams converted into 0.004 kilograms, and the right shows that the net force calculation is just the weight of the object in the y direction negative, and the velocity update formula and the position update formula. The output of this code shows the position non-linearly decreasing over time as the object speeds up, and the velocity increasing linearly in the negative direction over time, because there is no drag to slow it down. The Glowscript input for the drag model shows the same mass and everything else, but it also has the proportionality constant b of 0.005 through calculations. The net force is then equal to the weight, which is the same as the net force in the previous code, and the weight plus the force of drag. This calculates the net force including drag. Same formulas are below. The output of this shows that the position, again, non-linearly decreases over time, but in this case, the velocity is also non-linearly increasing in the negative direction over time. This is because the drag force is it's able to slow down the object, whereas without drag, the computational model cannot account for that. Here's a snippet of my experiment on Tracker and how I tracked it, and some of the timestamps to go along with it. The experimental data versus the computational model shows the blue experimental line, the computational with no drag line, and the yellow computational with drag line. We can see that the slopes of the blue and yellow lines are similar because they both account for drag. The red line is more symmetrical, and it also does not account for drag, and that's why it differs from the other lines. The reason that they may look a lot very similar at the start and start to diverge at the ends is due to compounding error over time of the experiment. Possible sources of error include inconsistent user tracking on Tracker and movement on multiple axes, such as the x-axis or z-axis. So by inconsistent user tracking on Tracker, I could have inaccurately tracked the point mass. Which graph predicts terminal velocity? So as we can see, the graph of the drag computational model shows the velocity versus time reaching a horizontal asymptote, which shows that it accounts for the terminal velocity, whereas the velocity versus time in the no drag does not. The terminal velocity would be the same if the ball was thrown downward, as we can see that both of these graphs account for the horizontal asymptote, and one of them has an initial velocity. Thank you.